Go. All right, we're live. February the 10th. Let's get into it. We have two messages. Let's see what's that. Trapping rainwater, huh? I remember that question. That's one of the hard ones. Nothing interesting. Let's see what's today. Copy list with random pointer. Oh, random pointer. Oh, what does that mean? Wow, the question is so long with so many hints. Okay, a linked list of length n, okay, is given such that each node contains an additional random pointer. What the hell? Random pointer. Alright. Well, you could point to any node in the list or no, okay? Construct a deep copy of this list. The deep copy should consist of exactly n brand new nodes, okay? Where each new node has its value set to the value of its corresponding original node, okay? Both the next and random pointer of the new node should point to new nodes in the copied list such that the pointers in the original list and copied list represent the same list state. None of the pointers in the new list should point to nodes in the original list. For example, if there are two nodes x and y, and you know where x star random points to y, then for the corresponding two nodes in the copied list, this relationship shall hold as well. Okay. Return the head of the copy. So basically, we want to just make a copy of the entire node, entire linked list, including the random pointers. Let's keep reading. The linked list is represented by the input output as list n, okay. Each node is represented as a pair of, okay, value, and then the index that the random pointer points to, or node if it does not point to any node. Your code will only be given the head of the original linked list. That's true. So yeah, basically just make a copy, right? You are making a copy. All right. Node right now is point to some node in linked list. Okay, let's think about it. We need to make a deep copy of this, and all we have is the node. We have the front, we have this, and we have next, right? So what we can do is, they say all the values are unique. I mean, we only have 1,000 nodes, so there are a lot of room to play with if we just want to pass this. But it did not say that the values are unique. We can just test this, see if the values are unique. Simple. We just make it 7. We can make everything 7. Ah. Right, that we're gonna return. Yeah, we're just gonna return the none. That's fine. We just want to test to see if it can be unique. Well, no, there's no requirement for it to be unique. So basically, cannot use value. I mean, it's very easy to copy the entire linked list without considering the random nodes. Now we want to consider random nodes. Oh, how do we identify the relative position? I mean, say this one goes here, but we cannot use we cannot use the value to identify them because we can have we can have the same, which means let's just walk. Like we're starting at the root, right? And well, what we can do is we can, oh man, we need some type of label, right? We need type of label. Label. Hold on. Basically, saying root is here, so we can go here, or we can go to a new node, which is what was a none. Let's do this. Like this one, I can create a new node, and the random node goes to another one. All right, it goes back in my copy. How do I know that the random needs to go to the front? How do I know? Well, once I create this node, I can put, let's say, like an index, right? Just an index. No, not an index. It should be. This is the key. This is the key. Key is the address of the original node, and the value is its copy. So we do this, we get a key, we create a new one, and we have the value. I mean, in Python, it's not an address. We just say it's a name, right? It's the object. We have this, and then we use this. It has to be hashable. But how do we get the address? Get address of object. ID. Yeah, we use ID. Okay. So we can use ID to get its address, and then we create a copy, and we also get that address, and we put it as a key and value, right? Key and value. So they're in a pair. So we go on. We create all the key and pairs, and then we run it one more time. So here, whatever we get, here we get this, and then yep. I think that one shall work. I'm pretty sure that the actual solution will include one that's like O1 in space, but mine is not O1 in space. It's we're using dictionary to handle this. Let's pass this first, and then try to think about it if we can come up with a better solution. But get it done first. Right? Let's get it done first. All right. This is old code. This is very old. See this? This is type hints back in the old days. We're talking about. This is like Python 2. I don't do it anymore. All right, wait. Probably shouldn't do that. All right, that's fine. We're not gonna do this. So what we're gonna do is we're gonna say original to copy. That is going to be a dictionary. All right, that's going to be a dictionary. And then we're gonna say how should we do this? Copy head equals node. All right, we need to say, so it's head. Let's just do this just in case. Head, it could be empty, so we should do this. If not head, return none. All right. So head dot x, not x dot val. head.val, and that's it. That's it. Because I want to do everything manually. So we have origin node equals origin node, copy node equals head and copy head. While origin node, right, we're gonna say copy node dot next equals a while origin node origin node equals origin node dot next, right? So copy dot next equals a new node, and the value is origin node dot value. All right, that's good. And then copy node equals copy node dot next, and then we keep going, keep going, keep going until this is a none. What if it's none? Oh, I feel like there got to be a better way to loop through this. We usually use like a dummy at the front. Maybe we'll make it easier. Because I feel like it's like not generic enough. Okay, original node equals original move to the next one. Then it could be none, right? It could be none. So we want original node to already be the next node. Okay, let's hold on. Let me think. I always like the dummy node idea. It always makes things easier. So probably get a dummy node as well. So we're gonna say copy dummy equals just a node. But you have to provide. It doesn't matter. Just provide a 0. It doesn't matter what it is. So we have a dummy, and we have original node is head, right? And then we say while original node copy dummy. Oh, we have to say original node original copy equals copy dummy, and then we say copy node dot next equals original equals node. Oh, it doesn't work. Oh, it does. Because original node, we know that it has value. And then original node go to the next, this one goes to the next. And once it's, next equals this, right? And then once it's done, we're good. And I don't even think we need this, all right? Let's comment it out. I don't even think we need this. All right, so original node go to the end, and this one go to the end. Perfect. Now we need to fill in the dictionary, which means while original node equals this. Before we move on, so now we are let's move the copy node. Let's move copy node on. So now copy node and original node are the pair. So we can say re copy id original node equals I can actually put copy node here, that's fine. Original node equals copy node. Alright. And then we finish. Then we walk the original node again. we walk again. And then every time when it is encountered, we just, if it's encountered, we, all right, how are we going to, do this? How are we going to, oh, we just go through every one of them. We go through every one of them. But you cannot go through every one of them. Hold on. What are we doing? We want to go through every one of them and then just look for its next node. Yeah, we just look for its next node. So it's the same thing. We have original node and original copy. So yeah, we basically do the same thing here. We want to walk the original node. So while original node, right? So while original node, we need to find its random node. Say rand node equals original node dot random, right? So we have the random node, and then we say, because we are going to walk the copies. Actually, we can actually do dot next as well, because we can put them like on the same time. So now copy node and original node are the same thing. So we say if random node is ID none, it does not, none has an ID. If say is not none, if it's not none, then we say original copy. What? Alright, I think I'm making this more complicated than it's supposed to be. We just say node and copy, and that should be it. Why you make it so much complicated? Not so complicated. Just node, and then this is just copy. Yeah, node and copy, node and copy. And we have something called copy node. And I don't like this name. We'll just call it dummy. I have a dummy, or a node, and a copy. And all the copy node, just copy. Yeah, just copy. And then we say random node is this. If random is not none, then our copy dot random equals origin copy this ID rand node. And node equals node dot next. Copy equals copy dot next. Okay, and we return dummy dot next. Okay, I think I don't need this. All right, but basically just do it 2 rounds, and then consider like cheating. I don't think so. I don't think so. Let's try it. We have plenty of test cases to go through. Oh my god. Node object does not support item assignment. What does that mean? Oh, this one is not copy or recopy. Okay. Oh, they showed one here. They showed one here. All right, empty list. Submit. Let's pass it first. Yep, we got it. We passed it. Probably not the best. I mean, pretty fast. People using few less space. But yeah, I mean, the idea is pretty straightforward. I mean, this solution, right? It's pretty straightforward. That we basically just use a dictionary to record a mapping to map the original node to our copy node. So every time when we check on the random pointer, it points to the original node, and we know exactly which copy node corresponds to that, and then we can just write this line, and we're good to go. So I'm gonna write a little bit here. We just say a very straightforward solution where we use a mapping to establish the connection between the original node and its copy. This way, when we need to create the random link, we know exactly which node. How should we express this? Well, we need to create the random link. We know exactly. I cannot make this into a coherent sentence. When we need to create the random link, we know the random. Oh my God, how should I say it? We need to create a random link in the copy nodes. We know exactly what which copy node corresponds to the original node that is the target of the random link. This is all ending in time. We had 32 milliseconds and 87% ranking. Okay, so let's write some comments here. The simple copy of the linked list without worrying about random link. Copy the linked list without worry about. No worry about random link. Traverse the linked list, filling the random link. All right. Can we do it in one pass? Probably not, because in one pass we don't know the connection yet. Don't say it this way. Most of the time I say it this way. There is a connection. So we're just saying, right? We're just saying. What I'm saying is we can definitely create the next one, right? Because that link is always there, and then like for here, like we go here, and then we know this one we already see it, so we can make it already, and then we create a new one. Right here, we're moving here, right? So we'll create a new one here, and then it's linked to here. But this one we don't know yet. Do we also create? We can create it and just save it in the. We can create it and then we can save it. So this one link this and we save it, but we don't because we just put it in the dictionary, right? We always follow here. We follow here, we go back here, that's good. And then when we come into the next, we have to check in the dictionary first. If it's already in there, then we just directly, yeah, we can do it in one pass. We can do it in one pass. We can definitely do it in one pass. But I'm not sure it's going to make it even faster, but it's a good challenge. We can make it in one pass, which I think we should do. It will be interesting to see how one pass can work. Yeah, let's try it. Let's just say this is just a little bit endeavor to make it a little more interesting. One pass. All right, so the starting point is all the same. The starting point is the same. We have the dictionary, we have the dummy node, and we have the node and copy. And then same while node, right? While node. But we need to check node.value. Okay. We need to check if ID node is in origin copy. If it's in it, that means we have encountered it already. Then what we do is copy.next not equal to a new node, but equal to original copy ID node. That's that, right? Else, if it's not in there, so copy.next will be node.val, right? After we finish this, we need to check the random node. So if node.random is none, is not none, just if node.random, right? If node.random, then what do we do? If node.random, then we say copy.random. Hold on. Copy is the node ahead of the current one. That's why we do the next equals. So once we have the next, copy needs to move forward. And then now copy and random are on the same level. Then we say copy.random. If node.random, we also need to check, right? If node.random, if ID node.random, all right, so we say rand node. Rand node equals node.random. It's a little bit easier to do this. Okay, so if rand node is in origin copy, right? If rand node is in origin copy, then copy.random equals origin copy ID rand node, right? Else copy.random equals node rand node.value. That's if the rand node exists. If rand node doesn't exist, we don't worry about it, right? And then what we do is actually is after we do this. right? After we do this, it's like the node is not in origin, right? Then we do our copy id node equals copy dot next. Actually, when do it at the end, there's a node on copy, and then we also need to do the random and the random as well. So if this at the end, so we can say ori copy id rand node equals copy dot random, like this. And we're gonna move forward node equals node dot next. And then we're gonna return dummy dot next. All right, very ambitious, this one, but we're gonna see if it works. I mean, the logic is a little bit more convoluted, that's for sure. Let's try. That's a good starting point. And we're gonna go here as well. Invalid syntax. Did I just type is in? Dios mío. Oh. I remember something was wrong here and I didn't. Did we fix it? No, I don't think we fixed it. Yeah, here. Yeah, I remember. Yeah, I remember this one. Anyway, let's run this again. How many times did I write this? Oh my goodness, I have another one. 2 times. Okay. How about a real test case? All right, so far so good. Let's give it one more shot. Yeah, let's just give it this shot. This could actually be an easy question. I mean, it looks complicated, it looks gigantic. Yeah, we got this one. What's the runtime of this one? Faster. Now I think we can make it even look even nicer, right? So like here, what we can do is just copy dot next equals origin copy dot get id node. If it exists, if it doesn't exist, node dot val, right? So we can do all these like that, and then copy next, and then we update this. And actually, this one is the same, right? Let's see if we can do the same thing. Well, I'm not sure. Okay, I need to check. This is a good question. Does none has ID? Holy moly, none does have ID. Yeah, none is an object as well. None has ID. Which is fine. None has ID. So if it's none, and we can say none equals, yeah, but it's not going to be, oh, I know. Do this, ID none is none. And then we don't have to even make the comparison. It doesn't even matter. So we can just go with copy.random equals origin copy dot get id node.random. Yeah, if none, we'll get a none already. If doesn't exist, node.random dot val. Let's copy.random. And then when we're done, we just reinforce it by saying origin, we're gonna get, this is gonna be node.random equals copy.random. And then we move node forward. All right, when I say this is copy the next node, and this one is copy the random node. And we think this is good. I mean, I don't know. Take a shot. None type has no attribute val. Huh. But I already put none in there. Why? None is a singleton. Why would it not recognize node.random? If node.random is a none, and it should return none, why would it return? Why would it go there? This is very interesting. Very interesting. So are you saying that? All right, I want to see print copy, not copy, print node.random, and then print node.random in or copy. Yeah, this is interesting. I want to see. False. Okay. Let's print or copy, and then let's print this, and then ID node.random. Tell me that these are like the none actually have different. Yeah, it's the same. It's exactly the same. It's exactly the same. Why would it not be able to get it out? 9788566. That's the same thing, right? So if I say ID node.random in RE copy, this should give me a true. Yes, it's true. It is true. All right. And then if I say but why would you even execute on this one? It's .get. Copy ID node.random. Yeah, I printed out. Oh, it probably executes this first and then do this. I'll get this. Yeah, I'm just want to try something. Get, let's say 10. It shall not print 10. Yeah, I know. It executes this one first. Ooh wee. That means if note dot random is none, we cannot do it. How do we write it? If it is none, then we just return none, which means I think we can do it this way. It'll be a little bit convoluted here. So that'll get. Yeah, I'll probably have. Let's just do it in 2 lines. So we're gonna do this, right? And then we'll say this if no dot random else none, like this. This shall work. Yeah. And then we can submit this. Yep, there we go. This is a 1-pass solution, which is not bad. I mean, it's a little bit convoluted here, but that's fine. And we want to see how good this one does. Doesn't matter. Just 1 pass. It jumps a lot. All right, let's take a look at the solution is not available. That's fine. We always go the problem. I think this is the easy one. Yeah, LeetCode's been throwing some soft balls these days. Oh, okay. So medium one, which is fine. Yeah, whichever I solved, I will upvote it. no, whichever I think is good. Solution with constant space, exactly. That's the thing. 2n, on. We have on, we have o2n, we have on time, on space. All right, we have to go for the on space. Oh my god. That is very long. All right, I just want to know. Okay, this person writes, ooh. Original after first while loop. Oh man, what is this? We add additional nodes. We add a copy node here. And then, and then we know that because the copy node is right after, so my target is also right after. And then we split them up. Ha! Give this guy a Nobel Prize. Now, this is a... Oh man. Stephen Pokemon came and then write something very hard to understand. That's fine, that's fine. We got the idea. We got the idea. Oh man, this is ridiculous. These people are trying to make things as short as possible and it become utterly utterly unreadable. Look at this. No, everything's. We understand. We understand the process. I might implement it. I might not. Kind of out of my juice today. Let's see. Let's see what they say about the OON. See what they say about the ON. Side by side. Second round. Copy nodes. Yes. Third round. Restore the original list and extract the copy list. How do we even do that? Oh, because it's that. So yeah, we can do that. All right. That's the O. Let's see. ON solution. A mapping. Yeah, a mapping. On time. This gigantic code. Yeah. All right. I think we have a clear idea of how this one is done. So the ON solution and no ON space solutions, we use a mapping, and we actually implemented O2N, 2 pass, and O1N, 1 pass, right? And the smarter one is O1 space, and we've seen how it is implemented. Well, we know the concept, but we have implemented. I don't want to implement today. It's kind of late. So we'll see. We'll see if I have any intention to do it later, or maybe tomorrow. Yeah, I probably won't do it tomorrow if I don't do it today. So yeah, let's not just pass it. I'll give it a shot later, but I'm going to end this right now. But I'll give it a shot on the smart solution and see if I can get it. All right, that will be it for today. See you guys tomorrow. Adios.